Hey, what's going on, guys? In this video we are going to see an example of ideal transformers. Previously I have done the same question using mesh analysis. Here I'm going to do a different method. Here what we are going to do is we are going to simplify this circuit and solve for this I1 and V0. Now let's see how to do that. First of all, I'm going to draw the equivalent circuit model together, like instead of this resistor and impedance separately, I'm going to combine them together and make a circuit. Now let's go ahead and do that. Here we have a voltage source that is 12 angle 0, and then here I'm going to combine this resistor and impedance together. So this is going to be just 2 minus 2j, and then here we have this transformer. Here we have a dot convention, and the voltage across this is V1. And then here we have a dot convention right here, and the voltage across this is V2. And I combine this. Here we have a 2 ohm resistance, minus 2j. So this is going to be totally 4 minus 2j. And the current going through this is I2. And the current going through this one is I1. Now what we are going to, and also the number of turns ratio is 1:2. Here I'm going to make an equivalent model for this one. To make the equivalent model, what we do is we can cut it from here. I'm going to cut it from here and keep the other one as it is. And I'm going to make an equivalent model. Okay. Now to make the equivalent model, first of all, we have to make a new impedance to calculate the. Okay, we have 4 minus 2j. And if I separate this one all together, there's an equation for this that is given by ZL A square is equal to ZL over A square. Now A is what? A is basically N2 over N1. N2 is 2 divided by 1. Now here we have ZL over A square, that is basically 4 minus 2j, this impedance, divided by A square is 2 square, and that gives us 1 minus 0.5 j. That's going to be the equivalent impedance we are going to place right here. So until we just remove this whole circuit and equalize this one to an impedance, and that's going to be, okay, let's write this here. Let's draw the circuit here. Plus minus 12 angle 0, and we keep this one as it is, that is 2 minus 2j, and then here instead of this whole circuit we're going to replace that one with whatever we find out with for this ZL over A square, that is 1 minus 0.5j, and that's it. Now here the voltage remains the same, that is V1 across here. And that's it. Now we are going to solve for the current I1. The current is basically the voltage divided by the impedance. Voltage is 12 angle 0 divided by the impedance, that is, if you add two of them together, that is 3 minus 2.5. 3 minus 2.5 j. And that gives us 3.07. And the angle is 39.8 degree ampere. This is our current. Okay, now we have the current and we have the equivalent model. Now our purpose is to find out the V0. Now we can make this equal. We can separate this equivalent model into two parts, like. Let's do it right here. Let's get rid of this one. This is one of the solution. I1 is one of the question. So we found out I1 here. Now let's continue here. Okay. Okay, let's continue over here. Now we have found out the I1. Let's draw the circuit again. This is plus minus. The voltage across here is 12 angle 0. And the impedance here is 2 minus 2J. Okay, now the voltage across here is V1. And also we have a dot convention right here. And again 2 minus 2J. 2 minus 2J, and then I keep the as it is. This is VO. The current passing through this is I2. Now V1, everything remains the same. This one is 2, and also I combined this 2 and minus 2J together. That's why we have 2 minus 2J. And I keep this 2 as it is. The voltage across VO. Okay, this plus minus right here. Now the next thing is our purpose is to find out VO, because we found out I1 first, that is here. The next thing is we are trying to find out VO. That's why we brought the same circuit back again. Now here we are going to do another thing to do this equivalent circuit. To do the equivalent circuit, what we do is we multiply N by ZL. N times ZL. N is okay, N square by N square times ZL. N is 2 over 1, that is N1 over 1, that is basically 4 times the load impedance, that is 2 minus 2J, and that gives us 8 minus 8J. So let's go ahead and draw the equivalent model circuit. Here we plus minus, and here first of all we have to know that I'm cutting to find out the VO. I keep the VO as it is and cutting the circuit completely and replacing everything. Here impedance is going to be 8 minus 8J, and also we have to change the voltage source. To calculate the new voltage source, what we do is we multiply N by, let's use a different color, N times voltage source. N is 2 times voltage source is 12 angle 0. So we are going to have 24 angle 0. And that's going to be the new equivalent model circuit. Now let's draw the circuit right here. Plus minus. And then this one is 24 angle 0. And the impedance will be replaced with 8 minus 8J. And that's it. After that everything remains the same. Here we have 2 minus 2J. And the 2 ohm resistor remains the same. 2 ohm resistor, and the voltage across this is V0. That's what we are trying to find. And everything else remains the same, and the current going through this is I2, and the voltage here is V2 in the middle. Okay. Now we are trying to solve for V0. Now we can combine these two impedance together, so we will get 10 minus 10J, because 8 minus 8, 2 minus 2, 10 minus 10J. Let's do that one over here. minus 10J. And the voltage across here is 24 angle 0. Now this is 2. Now let's find out VO. VO is going to be, here we are going to use voltage division to find out VO. VO is going to be 2 divided by addition of these two resistances. Addition of these two resistances multiplied by voltage source. So 2 plus 10 minus 10J, that's 12 minus 10J, multiplied by the voltage source, that's 24 angle 0. And that gives us 3.07 angle 39.8 degree, and that's our V0. And that's the second question. We have asked to find out I1 and V0. We found out both. This is our I1 and this is our V0. This is how we can do the equivalent model circuit to solve our problem. First, what we did is to find out I1, but we remove this half of the circuit. We kept the I1 as it is and found out the equivalent model. To find out this equivalent model impedance, what we use ZL over A square. A is nothing but N2 over N1. And we replace that one with this equal impedance and solve for I1. And here what we did the opposite thing. For this one, we remove this half part of the circuit because we want to keep the I1 as it is. But for this one, we remove this half of the circuit because we want to keep this VO, because we want to find out VO after this. So from that one, to find out the equivalent model, first there's an equation for the equivalent voltage, that is N times Vs. N is 2 and voltage source is given 12 angle 0, that gives us 24 angle 0. And also to find out the equivalent impedance in this side, we had to use N square times ZL, that is 4 times N square is 2, N is 2, so 2 square times ZL. We already know ZL is this resistance. We are talking about load resistance. So 2 minus 2J, and if we multiply 8 minus 8J, and that gave us 10 minus 10J. 8 minus 8J, actually 8 minus 8J remains, and we had 2 minus 2J in this side. We add them together and got 10 minus 10J, and we kept the 2 as it is because we want to know like clearly what is the resistance across this VO, because that's what we have to put on top, and addition in the denominator multiply by the voltage source, that's the voltage division, to calculate VO. And that's how we do that. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electromechanical system or circuit analysis, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.